Alright guys, this is a big disappointment. This is the next day and you can see it's leaking gas out of the carb here. Okay my friends, I had to hit the reset button on this carburetor for the generator. I'll just show you kind of what I've been up to, and you might see some of these ideas in the following clips and you might not, but I just wanted to show you where I'm at right now because I've kind of lost track. Sometimes I've been working on this carburetor generator thing with the camera on. Sometimes I've been working with the camera off. So I'm going to go back in after all this is over with and just edit up what I think looks good. So the original carburetor, which has the feed from the bottom, it kept leaking. It leaked and leaked and leaked and leaked. But it has what I don't like on the Makita carburetors. Oh, I just dropped it. 1 second. Here I was all set up and ready to go too, eh? 1 second. There it is. All right, not too bad. Not too bad. Okay. So this little tiny jet only has the spring on the top, right? And no rubber on the bottom. And this carburetor, I would put the jet in with the float. You know, if you've seen carburetors, you know what I'm talking about. This carburetor would leak 1 time out of 3 when I started the generator. I just think I had it, and then I'd come out the next day and there'd be gas in that little red tray. So then I took the needle out of this carburetor, which is the one I got from Amazon, I think. Okay, my friends, this might be the solution to our problem. Now, I ordered this carburetor. This was the only one I could find. It's kind of a Makita clone, but there's no numbers on it of any kind, eh? And I took the needle out of this carburetor and used it on here, and it had the little wire that goes around right there. And I'll show you the needle. You might have seen the needle before, but we are now in phase 3 of this operation, right? There's the needle, and there's the little wire do-hummer on the top. It worked better, but it still leaked a tiny bit. So it's starting to drive me crazy. So I got funky, and I got an old Briggs & Stratton carburetor, and the 2 shafts that hold the carburetor, I'll just show you that right now, were too wide apart or too close together, so I just took a Dremel with an auger and I dug these out a little bit so it would fit on. So I did this. And I got with the feed from the bottom, with the gas feed from the bottom, and it just ran terrible. But it did run. I mean, if you had to, I guess you could. What I think happened there was the breather, which is right here, was plugged by the gasket, right? You see how that breather hole is plugged right there? All right, Briggs & Stratton carburetor on a Makita Subaru generator. Choke. No choke. Fuel's on. Carburetor should be full. Let's see what we got here. Well, they all can't be successful, right? So then, what else have I done? I think that's about it. The next thing I'm going to do is remove this arm, the choke arm, and install the choke arm from the old carburetor that came off the Mikuni to the new non OEM Mikuni carburetor that was only $11 US or something. And I'm going to stick this choke arm on here because it has a different height on the actuator. You see that? Oh, it goes that way. So anyway, I'm going to use this one. And that's where I'm at now. So just give me a minute and I'll come back and we'll swap this arm out. Okay, so I'm just taking this last choke off of here. There's 2 screws. 1, 2, I got one out already. They were in there too, man. Holy moly. Okay. Choke plate and arm. Oh, we lost the spring. And the bottom piece. Good. I'm assuming the spring goes in this hole right here. Okay, so now we're going to install the new one. Are you with me? Yes. But we have a problem with the new one. Oh, did we get the spring in? Yes, we did. I hope it goes. Maybe we can use the bottom, the new bottom piece of plastic. Yes. Okay. So let's just see if this goes in there. Okay, so now we need the choke flap butterfly thing. Like that. Alright guys, I'm going to install this screw with thread locker because it had thread locker on it when it came out and I almost destroyed it. It's ugly, but it's going to work. And we'll just tighten them up a little bit. And done. Let's get the lid back on the thread locker so we don't lose that. Now we should have an operable carburetor. I'm just going to take the bottom off and check the float height because I was fooling around with that. And you guys can have a look at the needle at the same time, eh? Yeah, that looks a little high to me. So I'm gonna take this off and I'll show you the needle. You might have seen the needle before, but we are now in phase 3 of this operation, right? There's the needle and there's the little wire dew hummer on the top. There. I just flattened out this tab in the center right there. So it's a little more flat. Good. We put the needle on there. I don't mind the setup, it just feels flimsy. That's why I never used it to start with, huh? Okay. What's that converted song from, I don't know, some old Disney show? I-O, it's off to work I go. Feel bad for young people, and I was a young person once, swimming in debt. Now, I really do think the O-ring for this, I stole this O-ring from the old carburetor, but I do think the O-ring is a rubber one on this guy. I'm looking for all my, and I think it's this chubby one. Yes. Yeah, that's it. If it leaks, I'll just change it. I've had this apart so many times I don't even know what I've got anymore, eh? So now, upside down, we should have no leaks, although gasoline can sneak around corners like crazy, right? Okay, oh. Okay. And then upside down, when the float drops and opens the hole to the gas inlet. Okay, we are ready to install this bad boy. So let me just get my act together, guys, because I don't want to film and do this all over again. Okay, so there's the new carburetor I've never tried before. It's got the new, that came with it, the new needle, and I've got the old choke lever on there, right? You see that? With, what do you call it? With thread locker. I've got the new gas line. It has to, the gas line on this carburetor comes up. So I have to come up, and this one had a bend in it, and it comes bound. I'm going to one filter just for now. And now we're hooked up to the gas, so let's turn the gas on and see what happens. We'll let that fill, and I'm going to stick the bolts on there. So I'll be back when I get the bolts on. Alright, we're not going to know till later on today whether this is not leaking anymore, but we're going to give it a go test. So I've just put the bracket on the carburetor, and there's no thread for that third bolt, but I'm not worried about that. These two do a great job of holding it on. I might not even use this arch. I might just use extra flat washers on front of the carburetor. I might just use washers on there. But I'm using this ring so I don't mark the face of the carb. It should start and go like crazy. So let's just, I guess we can leave that there for now. Whoops, I guess we can leave that there for now. We should have gasoline flowing. So let's just put you on the magic chair. Back up a little bit. And we should get go. I'm still sitting on wood. So choke. Alright, now I'm gonna run it some more, but you guys don't have to see that. So it runs as good as it did before, exactly the same RPMs and everything. I just hope that the carburetor doesn't leak. So I'm gonna open the door, get the saw out, do the load test, and we'll see how we do. Thanks. Furnace alert. Alright, so I had a commenter on one of my videos, it was on the generator, tell me that I told him I was using the Makita 13 amp circular saw, and he said that it would only draw a couple of amps unless it was under load. So I thought, yeah, that's probably right. But I thought, there's no way of finding out unless you prove it. So to prove AC current, you need a clamp meter like this. I don't know, I think I paid $9 or $15 for this. And what you have to do is there's an inductive field around every wire that has current going through it. So these little meters actually measure the current that's measured, that's going through the wire on a conductive measurement. So I'm going to hook this up. It plugs into the generator, and then I can clip onto the end of the extension, or the end of the cord for the circular saw, and then I can put this on here, and we'll actually see how much current is being drawn by the saw at startup, and then we will observe, after it settles down for a few seconds, what the current at non-working state is, and then we'll do it 2 or 3 times just to make sure it's consistent, and then we'll come back. That's going to be a lot of fun. So we'll start getting it hooked up. We have to plug this into the generator, and we take right down here, sorry. I do this all the time. There's our saw. We take the saw and we plug the cord into the, now you got to be careful when you're doing this, but I'm pretty comfortable with electricity. And then we actually measure the current through the wire with this, the field. The stronger the field, the more current you have, and we'll measure the amperage on this little meter. Now it's really loud, so I'm going to do it separately. I can't talk when the generator and the saw is going, as you understand. And we'll come back. Thanks. So it was around 5.7 amps running without a load. That's pretty cool. It was a little higher than I thought, but it did draw right around, pardon me, it did draw right around 13 amps when I squeezed the trigger right off the bat, the initial load. Like every piece of equipment, furnace motors, anything has a high initial load, and then it goes back to a running load unless it's cutting wood. Like if you were cutting a piece of oak, this would probably be right up around 12 or 13 amps. So what a great little demo. Thanks guys. Just fooling around in the garage. Must be springtime, eh? Bye.